Hello, so try to solve this question 1-3 from your quizzes. A uniform beam is 6 meters long and has a mass of 45.87 kgs. It rests on two supports, each 1.2 meters from the nearest end. It carries loads of 900 newtons, 1350 newtons, and 1800 newtons at distance of 0.6 meters, 3.5 and 6 meters respectively from the left end. At what distance from the left end must an additional load, 2250 newtons, be placed so that the support reactions are equal? So from this, we need to highlight this information. Step 1. Convert information to a diagram or just a sketch. Step 2. Free body diagram to allocate the support reaction forces and direction arrows. Step 3. Support reactions are equal. This is a hint of information given here. So for us to know that in the question stated support reactions are equal. Step 4, place 2250 newtons about a distance x from the left end of the beam. So let's try to convert this question. So if you look here carefully, what do we have? We have first load 900 newton is about 0.6. So if you're wondering, this is the left side. So let's write it down here. This is left side. So this is where I'm working on my left. So this is the left, if you confuse yourself. So 900 newtons, about 0.6 from the left. And then you have 1350 newtons from the left. And you have 1800 newtons, about 6 meters from the left. You have the weight of the beam, which is a mass given to us, 45.87 kgs, times gravity acceleration, will be converted to around 450 newtons. So this will be in the center, so will be divided. So if I add all of it is 6 meters, so this distance represents for me 3. So I will show you if you just in case you get confused. So the distance from here to there, it should be 3 meters. So this Control V, so this one is 3 meters. And the same thing, if we try to take the same, this should be also reading for me 3 meters. Alright, so that's where is the weight is always in the center. Alright, now what do we have? It's telling us that there is an additional load of 2250 newtons will be placed at the distance x. I really don't know where is this x, so this x could be here, could be there. So wherever that's a value, we need to find the value of x, wherever is location. We definitely know it's going downwards. Now, if we try to draw the free body diagram, so for this question, free body diagram, we locate the support reaction A, I will call it the first support reaction, and the second one I will call it B. Now, after allocating the support reactions, we need to write the equation to determine the support reactions. So what equation works for us, which is summation of forces in the y direction. So I assume in the second question for me, for example, here, I will say this is my x direction, and that way is going upward to be my x direction, y direction. So that's represent for me the support reaction for the positive y. So let's try to do it in the next step. So in this step, what we're trying to do, summation of forces in y direction is equal to 0. So you will have the forces on top equal to the forces going upwards. So going up is positive, so I put the arrow here to make sure it's going to the right direction. So this is the positive and it's going up. So what do you have? You have 900 newtons going down. So technically, because I put it in a way to show you the equal is distinguishing between me. So this will be 900, what you have 1350, 1800, you have the 450, and then you have the 2250. All of that will equal against what? Support reaction A, support reaction B. Because in the question is stating for us that the support reactions are equal, therefore I will say A plus B is equal to A. I just take one of them, because they have the same value. Rearranging this equation, you add these together is equal to 2A. then A is equal to what? You divide the summation of all of that divided by 2, and that will give you a support reaction of value 3,375 newtons. So this is the value of the support reaction we're trying to find. Now, after we found the support reaction, so I need to update my information here. This is equal to 3375 Newton. I'll just put it so you can see exactly what we're doing. And then this value, because A is equal to B, so A plus B is equal to A. And that's what we're trying to say here. So that will be equal again 3375 Newton. And then I will put that in that way so I can explain to you. So now we found all the support reaction values, both of them. We need to determine the x. The only way to solve that is you just need to take the moment. So I will take the moment around this point A, a moment around this point, and I will assume the counterclockwise will be the positive. Alright, so taking the moment, we're assuming the counterclockwise is positive, or we can assume actually instead of that we can assume the clockwise. Let's make it like clockwise is positive. So clockwise is positive. Okay, so that means this direction going is positive. So let's take, what do you have? We start from this point. Now 800, but see carefully where I'm taking the moments around point A. So that arrow should stops at this point, technically stops here. And if it was 6 meters, 6 meters minus what? The value of 1.2. Now you say, where did you get this 1.2? So look carefully. 6 meters is the total length minus 1.2 will give you the answer for this one is 4.8. Therefore, I did right here 4.8. So that's a distance to A. Now the same thing, let's try to do it for this one. So for support reaction, we'll be going in that way. But let's try something else before we move that way. Let's try this x, for example. This value, the distance to that moment, what will be? To that point, so I will bring the arrow here. Its mean will stop to that point. So that will be x minus what? 1.2. Perfect. Because that's what is missing. So the total of that was x. Now minus 1.2, that's where is the value of x. Therefore I wrote plus, because this will rotate in clockwise, 2250 x minus 1.2. Now let's look to the other one. What do we have the other one? We have this support reaction. So this support reaction at B, the value as we know it in advance, what's the value is equal to? Equal to 3375 newtons. So this 3375 newtons is equal to what? From here till there, because I subtract 1.2 and 1.2 will be the distance we're trying to allocate. So I will show you how we can allocate that distance. This will be around that point, and we can just select it. So if you add these together, the answer for this is equal, that distance is equal to 3.6 meters. So from that point to that point where we're taking the moment is 3.6. Now why I took negative? Because this will rotate against my assumption. Now we go to the second load, which is this one, 1350 newtons. The distance from here to the end, to the left side, remember this is where we say this is my left side. So I'm putting here the indication left side. So that's, we don't want that distance, we want to take it to where we are taking our moment. So that will be 3.5 minus 1.2. Again, where is the 1.2? Is this one. This is 1.2. That should give us an answer. So if you try it, will be giving you 2. So equals 2.3 meters. Now what's next? So everything we're taking is about that point. Now we need to do it the same thing for the mass. So the mass is 400. The mass will rotate clockwise times 1.8. So you see the distance to that point. Now, what's left? We have this force. This force will rotate in that way. So if you hold your point, we try to push the beam to rotate in that direction. The distance from here is actually all of it's 1.2 minus 0.6. Therefore, we write the 0.6. It's from here to point A. So if now I just sketch a line here to tell us what's exactly what we were taking into account. We were trying to take the moment around this point to make sure everything is going through that point, and that distance from here is 0.6 is equal to 0. So now we have one equation with one unknown, which is x. Rearranging, so I put the equation with x on one side and the other variables on the other side, and then x minus 1, 2. So I divide the answer of this one divided by 2250, x minus 1.2, and then x will be 0.06 plus 1.2. Rearranging, that will give us 1.26 from the left. So here is a very important thing which we need to highlight. So this is the answer, but really you need to be sure that this distance is not that's a small, that's 1.2 minus 1 minus 1.2, which is giving you 0.006. So technically, if I try to solve this question, I'll resketch that again. So to correct that, this should be technically, to be more accurate, should be about that distance from, it's actually very small distance, should be around that distance, and that's equals to, if we write the number, equal to 0.06. But that's not the answer he wants us to know. He wants us to know, if you see, what distance from the left. So we want to find the distance from the left. So to extend that to the left, it should stop here, and to write the right answer from there. So if that was 1.2, 1.26, and to be very precise, this force, so let's say it should be just after the support reaction by slightly 0.06. So that's exactly where it's located, and that's the final answer. I hope now the solution for this question is very clear for you. I'll try to see you in class this Friday. Otherwise, enjoy the video. Good luck. See ya. Bye bye.